We all want to write reliable software, but how? I often think of software reliability in terms of time. If there's a bug, you are going to find out about it eventually, and the pain of that bug is often proportional to the time it takes to bite you. The longer it takes to realize, the more it's going to hurt. The most painful time to find out about a bug is when lots of users have hit it and started complaining. Faster than that, slightly less painful, is when you get paged at 3 a.m. because the server crashed. That still hurts, but at least the users are asleep. It's not quite as public. It's going to hurt less. Tighten the feedback loop even more to before it goes into production, and you've got things like QA departments reporting the errors. And I find that painful. I find it kind of embarrassing that I didn't realize before it went out, but it's less painful. And you keep trying to pull that feedback loop as far as you can, and eventually you get to things like a Haskell compiler or a Roc compiler, which can tell you you've done it wrong almost immediately and won't hesitate to do so. It's like being slapped in the face privately, and that is about as painless as it's going to get. My central thesis is, when you've got bugs, pain is guaranteed, but timing makes all the difference. Does that sound familiar? Does it sound jaded? Does it sound realistic? Let's leapfrog over that question and talk to someone who is at least optimistic about techniques for getting tighter feedback loops, and in the end, more reliable software. I'm joined this week by Isaac van Doren, who is definitely a bit wounded from bugs in the field, definitely wants to make things better, and is a fan of techniques ranging from the familiar but somewhat overlooked ones, like assertions, through to whole system monitoring, to some more exotic techniques, like the way Roc builds tailored platforms for really focused environments, or the way Zig does runtime bounds checking. How much should you do about software reliability, and what should you ask your language and your environment to do for you? If you want more reliable software, or at least less pain when it's unreliable, Isaac has some suggestions. Before we get started on that, this episode was recorded live at Code Remix 25 over in Miami. So thank you to Modern and Open Rewrite for being our hosts for this. And as if the gods were messing with us, ironically enough, for an episode about reliability, my camera overheated partway into this episode, and it cuts out for a few minutes. So if you're watching this as well as listening to it, my apologies, it does come back after a few minutes. No, I was not tempted to use AI to try and fake the footage back in. Yes, I was slightly tempted to try and do it with sock puppets for the laughs, but I think it's best I resisted that temptation. Let's go and get to the real human beings. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Isaac van Doren. Joined today by Isaac. Isaac, how you doing? You've just come off giving your talk. How are you feeling about it? How'd it go?
Doing great. I think it went pretty well, and it always feels wonderful to be done with the talk. So I'm riding that high, knowing I don't have to think about it anymore. It's freed from my brain. So.
I'm glad if you consider doing this to not be part of the stressful process.
I've gotten half of it done. So
yeah, I'll go easy on you. I'll give you a little bit of a grilling, but we'll see how it goes.
No, grill away. Okay. Don't go easy.
Okay, so I was thinking. You said during your talk you mentioned that you're 23, right? And which struck me as quite a young age to be so jaded about the reliability of software that most of the stuff you're doing is trying to make it more reliable.
Yeah.
Have you been bitten really badly, or are there other constraints in your life?
I don't know. I was thinking about that earlier today, actually, thinking about why do I care so much about software being reliable? And I don't know that I have that great of an answer, but if I have to take a stab at it, I would say that even if it hasn't bitten me horribly, every day I interact with software that's broken in some capacity. And to give an example of this, my grandmother cannot get into her medical records software. We were helping her get set up so she could access her records. We created an account. it was a little bit rough, but it worked. But it gave her this massive auto-generated username with a ton of characters in it. So my wife said, okay, we'll give you a nicer username that you can remember. We tried doing that, went with the same exact steps. Their flow to change the username, locked out. And it's been multiple months now, and she can't go in to access her medical records. So she instead drives over to the clinic and asks them to look things up for her. So that's just one example. And that was completely unsurprising. No one was surprised. It's just, oh yeah, this is how software works. It breaks all the time. So I don't know. It's just like the common experience of using any software is that it breaks and crashes and does weird buggy things all the time. And that's an unacceptable standard for me.
Yeah. And it's definitely like, I get the same thing with my father-in-law, right? He just expects software to be broken all the time. And he comes to me for tech support and he's constantly saying, like, how do people that don't have a geek in their family cope?
They just suffer.
So,
and I think that's an important thing to point out here is that sometimes we think the number of bugs in my backlog, it's just this sort of abstract, amorphous, we have some issues. But these issues really impact people's lives. Like I work at a company where it help people pay for healthcare. So if we do something wrong, it could mean that someone can't get the healthcare they need. Or maybe if we charge them the wrong amount, then they're losing money, then we're breaking the law, then we're giving them a horrible experience. So software being broken often has really severe consequences.
Yeah. I'm trying not to... This is a big cultural dividing line between
right.
Europe and America. Paying for healthcare, yes, I can see that's super important.
NHS has software that can break as well.
Yeah, it definitely does break, but the billing is a separate issue. Okay, but yeah, so we all experience bugs being horrible. I can see why in the healthcare industry particularly, you would be doubly worried about that because it's an important issue whether you're paying directly or not.
Right.
What have you discovered? Let's take it from this angle. So you are young enough to realize that bugs are always going to be with us and causing us pain. But what techniques have you found work for making software more reliable?
Absolutely. Well, as a starting point, I think when everyone thinks about software reliability, they start with testing. They think there is a bug. That means we need to write more tests or better tests.
For a while, we were told that was going to solve all bugs forever.
Yeah. And it's absolutely true that testing is incredibly important. Many times bugs slip through because we have bad tests or not enough tests. But that's just like one slice of the huge pie of software reliability techniques. And I think there's a lot to be gained from taking more of that pie and introducing other techniques that work together for software reliability. So one that I've introduced recently at work is the use of assertions. And so we run assertions in production that if an unexpected condition happens, they will cause that code path to fail very loudly and explicitly. And there are other things I can talk about, but maybe we can start with that.
Now I'm going to dig into assertions because I see the use of assertions, but they are like they're somewhere beyond guardrails they lie somewhere between a guardrail and just a segfault, right? Stop the world, something I didn't expect to happen. Let's just crash the whole thing.
Right.
Do you find that in practice they catch things in a good way?
Absolutely.
Yeah.
And
convince me.
And I'm glad that you're skeptical because I think you should be skeptical because what I'm suggesting is that you take a bunch of little bombs and scatter them throughout your code base.
That's how it feels.
And that's how you should feel because that is literally what we're doing.
Like I do that in Rust and I type panic. It's like,
right.
Yeah, it should make me panic as well as the code.
Right. So to motivate, it's part of the reason that I wanted to start using assertions is that I noticed scenarios where there was code that existed that code new to me. I was trying to understand it, figure out how to modify it in some way. And I look at it, it's just a big blob of code. I don't know what's going on. And then after I dig into it more, I find out this chunk of code only exists here to handle some possibility that should never happen. If that ever happens, it means there is a bug. That is the only explanation. So why do we have this extra code gumming up the code base that's only there to handle something that should never happen? And then There are other situations where, that's sort of the understandability piece, that when you use assertions, then it makes it easier to understand your code, which we should come back to that. But on the reliability piece, the main motivator there for me is that if something that should be impossible happens, all bets are off. I have no idea what's going to happen. Something really bad could happen. It could be that now I charge someone twice as much as they should have been charged. That could absolutely happen. Stuff like that happens all the time.
Yeah.
I would much rather explode, stop execution in a loud way where I can say, that's a bug, I need to fix that, instead of letting that code palette going on and cause some worse failure. And the trouble with a failure like that is you might not even notice. And lots of software is broken in ways that we don't even have any idea about. And I'm sure that there have been many times that I've been charged too much that I don't even know about, because what way would I have to determine that I've been charged too much? Or I'd have to be combing through everything so closely to identify that. So part of this is pulling these bugs out sooner instead of letting them continue on further.
So that makes me think of two things. The first is the technical one. Is there a distinction between an assertion and just throwing an unchecked exception?
Absolutely, yeah. So that's one of the main motivations, is that when something impossible happens, I want to know this is a bug, not this is a normal error that I expect might happen. So and that's part of the point, is that lots of code bases will have tons of errors showing up because things that you expect to happen that you can't handle, that they're somehow problematic. And if you say this is a bug and I'm going to throw that same sort of error, just throw it into the pool, well, someone else might handle that error down the line, or maybe it bubbles all the way to the top, and then it just goes into the sea of red in Datadog or whatever, and you have no idea that that's a bug. So I wanted a way to say specifically, if this happens, it is a bug. So that's the way we use assertions. If any assertion ever fails in the code base, that means there is a bug. That's the golden rule of writing assertions for me. And so ideally it means there's a bug in the code somewhere else, but it could also mean there's a bug in your understanding of the program. That assertion, it's actually okay for that condition to happen sometimes. And then the bug is the fact that you put the assertion in there.
Yeah. So would you like to see language support for this kind of thing? Like Rust has unchecked exceptions where you can say, this is definitely a bug because an assertion has failed, but you can also say, this is a bug because we haven't written that code yet to do.
Right. Yeah, it's certainly useful to have language support, and I'm glad that languages have support for it. In our case, we use Java, and the way we've chosen to implement it, so Java has built-in assertions. When one of those assertions fails, it throws an assertion error. That's an of type error, not of type exception. And so those aren't normally caught if you do catch exception. And so, but we chose to roll our own for reasons I can get into. So we throw our own type of error. It's an invariant violation error is what we call it, so that it can't be caught anywhere else. And we know this specifically means there's a bug.
I'm going straight into why write your own.
It might have been fine to use the built-in assertions, but I was a little bit concerned because oftentimes the methodology for using assertions is I'll put these in my code, I'll have them turned on in development, but then I'll turn them off when I get to production because I don't want these to blow up in my face, or I don't want the performance penalty. That's totally backwards, because then you're not getting any validation that these things aren't happening in production.
Yeah.
So my stance is instead you should run them in every environment. That's like rule number 2. All assertions should run under any circumstances, because then you never have to worry about, if they're inconsistent performance between different environments, or inconsistent behavior because your assertions are actually somehow contributing to the behavior of your code in a way that you don't understand. And so given that there's that attitude of not running assertions in production, my concern was that some of the libraries we were using might have been using assertions in a way that we would not want to be running in production, say in one that would impact performance too much. And I don't know, that may not have been the case. It could have been fine, but it was incredibly easy to roll our own. I mean, we just created a class that with a method that takes a Boolean and a string describing what happened, and it throws the error if something went wrong.
Did you suggest this at work? Did you get buy-in? Are you somehow policing the use of assertions?
I don't know if I'd say I'm policing it, but so we have an RFC process where anyone can propose some sort of change to the process, we have an argument for it, and then people can comment on that. And then once that goes, if there's agreement, then you go for it and implement it. So I proposed one of those, implemented it. We have two big, main, monolithic, well, not necessarily. We have two big main products.
Don't use the M word.
Yeah, it's been implemented in both of those products. Okay. And I'm certainly the person who's used it the most so far. We've had them going for about 6 months or so, but I think an engineer from about every team, every of the 8 or so teams has used them. So we're getting them adopted.
I have to ask, have you ever had production code crash because of the assertion? I assume you have.
Yeah.
I wonder how that was taken, because now the application has crashed and it's kind of got your name on it.
Yeah, no, that's a great point. I've certainly thought, like, man, I hope this doesn't cause some horrible incident or something. But no, it has not happened very much. And when it has happened, we've been glad of it. So early on, an assertion that I wrote failed. And I was surprised because I was encoding this expectation I had about how the system worked. And I looked into it, and it uncovered this bug with payments that was impacting like 500 users that had been in the system for 3 or 4 years, and no one had even noticed because it was a small enough group. And fortunately, it didn't manifest in any way that caused real harm, but it certainly could have. It was not a great bug to have in there. So that happened kind of early on, and I think it's set things up in a nice direction where I could say, look, this caught a real bug that was quite bad. So now, you should be happy that we have these in place.
This always makes me think, like, sooner or later, bugs in software will bite you. And the worst possible time for them to bite you is you heard about it from a user that's complaining. Absolutely. And anytime you can pull that back to earlier in the cycle. But that makes me think, like, you I know, are a fan of Roc and statically typed functional languages. So let me just say something deliberately incendiary to see what you say to it. You could argue that runtime assertions are a poor man's type system, and we should be catching these things at compile time. What do you think of that? How do you feel about that?
Well, you, the statically typed functional programmer, of course, would say that. I anticipated this beforehand. And because there's a lot of truth to it. If you can catch something statically at compile time, you absolutely should catch it there. And that's, in the talk I just gave, that's one of the things I talked about a lot is, hey, look, we can build languages that catch more for us statically. So the idea I think of it as this sort of funnel here, where at the top, the best thing you can possibly do is to rule out errors at compile time. They'll never show up. It's completely obvious. You don't have to worry about them ever. But that only gets you so far. So the next layer is that use assertions at runtime, because there's so many properties that can't be encoded in the type system. So I gave an example in the talk about, say, when you use tag unions in a functional language, you can encode perhaps more than people think, like explicitly saying which combinations of fields being present are allowed, for example. Then you never have to worry about a null pointer exception or something like that, because you're encoding the logic about when these fields can be present or not with the type system. But there's so many properties that you can't encode with the type system, like most of the properties. And this is where I think the functional programmers go wrong. The thought is, look, we can build a better type system that catches more stuff. So we just need to build an even better type system and until the type system catches all of the errors. I don't think that's at all realistic. I'm sure there's more room to innovate. We can have dependently typed languages that can check the lengths of lists or things like that. But that doesn't mean the type system is going to be able to check all of these business rules that apply to your specific data model, or that the date is not in, that must always be in the future is in fact in the future and not in the past, or that you're doing your math properly or things like that. Those start to get outside of the purview of what the type system can prove for you. Okay, so you're on that spectrum of catch it early as you can, but no earlier. I'm not sure how you would catch. Well, I'm certainly of the fan that you should, of the mind that you should catch them as early as possible using your type system. But the trouble is that then we run out of room where the type system can't help us anymore, and then we don't catch the errors at all, and we just let them run rampant in the code base.
Yeah, that's definitely a mistake.
And so So with a type system, you get instantaneous feedback. You find out about the error before it makes it out into production. Then I say, once you run out of room there, start using assertions. Then you can say, I want to find out about this bug the moment it happens, instead of a month later. And then we can talk about even a third layer of this pyramid that I have, which is you can't even enforce all of your properties with runtime assertions for perhaps performance reasons, or they need to check too much data. So then you should do asynchronous validation that happens maybe on a nightly cadence or things like that. But before we get into this, there's more I need to say about this direction. So first, the way your assertions cause your code to fail should be very tailored to the domain you're working in. So we're writing web servers. That's where we're using assertions. I definitely don't want the whole web server to go down if one assertion fails. So if an assertion fails, we have it implemented such that it'll be handled at the top layer. So that whole request will fail with 500, but nothing else in the server will be impacted. So this doesn't mean if something goes wrong, production is completely down, everything is on fire. It means that one branch encountered something impossible, a bug, now that request is going to fail. So, hopefully your whole camera doesn't fail or something like that. Maybe if there are different systems, the subsystem in the camera that ran into that error will fail and restart.
This is why we have a camera that can fail. We have backup audio recorders, right? Yeah.
And then the second thing is that assertions are really just a name to use to talk about the more general idea, which is thinking about the invariants that must hold in your system and enforcing them. Or you might say the properties. When I say invariant, I mean some rule or some statement you can make about your system that must always be true under every circumstance. And that's really why I want to use assertions. I want to push people to think about what invariants apply in your system and then make sure that they're being enforced.
Do you have guidelines, like even rules of thumb, for what makes for a good assertion, then? What makes for a good invariant to look for?
Yeah, my main rule, my golden rule, is that if an assertion fails, it means there's a bug. And so that rules out, to unpack some of the consequences, that means that you should never be using assertions to validate data coming from an external data source.
Okay, yes.
So you expect that people are going to put bad data into your API. You need to have validation there that it does the expected path of error handling. But if you're using in some internal part of your code base that has entry points from various APIs, and you end up with some nonsensical data, that indicates that there's a bug because you're missing validation at one of those outer layers. So that is a reasonable place to use an assertion.
Okay, yeah, I can see that. You are touching on two things, and I think the next one I'm going to go to is you talked about like a web server, putting assertions in a web server, and like that particular request fails. So the first thing I have to ask you about is monitoring. It's not enough to just put an assertion in. What are you doing about making sure someone notices?
We didn't talk about this, but I'm so glad you asked that, because that is absolutely the next question. So when an assertion fails, because we have a specific error type for that, we handle that specifically. In our case, we emit a log message saying, hey, an invariant was violated, an assertion failed. Then we have a monitor that will trigger a low priority alert in PagerDuty and quietly page whoever's on call to investigate that. Okay. So the idea here is that then once this breaks, we will tell you loudly and clearly that it broke, so you have to go investigate it now.
So is there an assumption that, or is there kind of a mandate that whilst you think assertions are good, they're not enough on their own, you need to have proper monitoring in place to...
Well, yeah, if you don't know when an assertion fails, then it's not doing you any good, because then it's failed. The bugs are still happening and you're not looking at your logs and you don't know that they're happening. Yeah. So you need to have that feedback loop. And this, they work into a really nice feedback loop that also pulls in the other things you should be doing to build reliable software. So if I put an assertion in my code, I'm putting a little bomb in my code. I want to make sure that bomb doesn't go off, because if it does go off, I know that I'm going to get paged, and then I'm going to have to worry about fixing this the next day. I don't want to do that, so I'm going to write more tests to make sure that assertion is never hit. They force you to commit because you're saying I'm confident enough that this should never happen, that I'm saying you can explode if it does happen. And so if I'm going to make that commitment, I'm going to do the other things that I should to make sure that I am following through on that.
Yeah. This may be an unpopular thought, but I think that's one of the strong reasons for having the programmers be the people on call.
Absolutely.
Because you need that feedback loop.
Because if someone else is worrying about it, then who cares? That's the programmers need to be the people dealing with. Programmers need to be the ones responsible for your system operating correctly. And surprisingly, I think that's a little bit of a controversial statement. Where some people have the idea that there should be some sort of product support team, perhaps, whatever you want to call it, that will investigate, there's some data issue or something went wrong, all this, and then they're going to fix it, and I'm busy shipping features, and that's what I'm worried about.
Yeah.
But that's ridiculous. You should be responsible for the thing you're building and making sure that it works properly. And once you do that, then all of the incentives start working in a virtuous cycle where you don't want to fix it, so you're going to make sure that it actually works the first time.
Yeah. You also get this thing, I think I've seen this in the past, where in a company where the programmers get to throw their code over a wall and never worry about whether it worked or not, they overestimate how good they are at writing reliable software.
Absolutely.
Because we all need feedback loops. Right?
Absolutely. Yeah. And another reason I like using assertions is that we don't realize how bad we are at writing software. And it's nice when you have something checking your work, pointing out cases when you do something wrong. And there may be a lot more cases where you do something wrong than you think. Maybe they happen to not be relevant then, and so they sort of go unnoticed, but this draws them out immediately, so you know right when they happen.
Mm-hmm. Yeah. Okay. So the other thread I was tempted to go down, and I'm going to get away with this because you're a language investigator, right? You've got a web server, you've put an assertion in your web request, so it just crashes. You're going to let it crash. I pick that phrasing deliberately to invoke Erlang. It is actually the right thing. What are you doing about... Are you tempted to move everything to an Erlang-like language that has a supervision tree and crashes are expected?
No, not at all. I mean, and that's not, Erlang is one that I have not explored much, although I'd love to. It sounds very interesting. But my understanding of that idea of letting it crash and then recover is that you're expecting it to crash as a normal part of operation. I'm not expecting, if an assertion fails, that's an exceptional event. That's not my normal mode of operation here. If an assertion fails, I don't really think that restarting that somehow and running the same thing over again is going to have any different effect, because the reason it failed is there's a bug in the code that I wrote. So why should I retry it? The code I wrote doesn't work.
Okay, I can see that. Yeah. So I think you might be seduced one day over to Gleam, for instance, which is very much in the family of Roc languages.
Right.
So you're using Roc as a kind of hobby language.
Right.
You're using Java at work.
Yep.
Do you wish... What is it that attracts you to Roc, and what do you wish you could port across, assuming you can't persuade them to start using Roc?
Well, everything. I'll port everything to Roc.
Okay.
But the fact is that I am not of... I think rewriting a large software project is usually a bad idea. And so I'm not going to say that we should rewrite all of our code in Roc just now. And on top of that, Roc is young, and the compiler is currently being rewritten, for example. So once it's matured more, then I might have more thoughts about, integrating it some places and starting to get some of those benefits. But it has to be really good before you should start using it in production. I mean, it's excellent, but the I's have to be dotted and the T's have to be crossed.
Okay, yeah, that's fair. So one thing I noticed from your talk about Roc, which I didn't know before today, was there is a U64 type, right, which I assume is an unsigned integer, 64-bit integer. And I also know that Roc is currently being rewritten from Rust to Zig.
Correct.
So you've got... One of the things that makes Rust and Zig distinct is Rust will do memory checking for you, whereas Zig won't. But Zig will do bounds checking on that unsigned 64-bit integer, whereas Rust doesn't.
Mm-hmm.
And like, even in these languages that are so concerned with getting things right at compile time, you still have to make trade-offs over what's checked for you for free. And where does that come into a language like Roc, which is checking things at compile time? Does it have bounds overflow checking?
Yeah, no, that's a great question. You're very sharp. Because that's sort of the one hole in Roc where I can say all of these errors are caught at compile time. They're all made explicit. There are no errors you ever have to worry about secretly showing up. There's one caveat, which is the integer types, that they can overflow and things like that.
It surprised me that it had like a fixed size integer type.
So there are methods that are checked and unchecked methods for those integers. So you can use a checked method if you want that returns a result in that case. And yeah, I don't know if there's that great of an answer to this because it's so vastly much better for performance to use the raw integer types rather than having an arbitrary length integer doing this checking.
Yeah.
And Roc cares a lot about performance. The goal, it's a memory managed language, and the goal is to be at least as fast as all of the mainstream memory managed languages. So Go, Java, Swift, C#, all of those.
Okay.
And you can get much better performance if you use the raw integer types. Now, you could certainly implement a type that is arbitrary length or has the checking, and you can certainly use that and implement that language, but that's just the choice that's been made. And I don't have a great answer for you. It's unfortunate.
Okay, fair enough. It's we're always going to be making trade-offs because there is no one language that gives you all the different safety features you want and leaves the safety features you don't care about on the shelf. I wonder if we might find 10 years from now that you're starting to build one that starts to weave these things together.
Roc is certainly my ideal language at this point. I haven't come up with one that is much different from Roc, but hey, there's lots of room for innovation, so it might happen.
Or you might end up building a Roc platform that has a supervisor tree. Who knows?
Yeah, a lot of people are excited about the idea of building a Roc platform on the beam to do actors written in Roc. I don't think anyone's done it yet, but you can absolutely do it, and there are a lot of people excited about that.
Can you tell me about that? Because I'm interested in the whole Roc platform, how wide it goes. So, for the sake of the audience, explain what a Roc platform is and how practical it is to create one.
Right. So, in Roc, every application you write exists for a specific domain. This is how we write applications in any language. I'm writing a web server, I'm writing a CLI, I'm writing an editor plugin. You're only ever writing one thing, and yet you use the same language with all the same set of tools. All of those primitives in the language may not all make sense for the different contexts. For example, maybe the JVM is really nice when you're building a web server, but you don't really want to have to deal with a JVM when you're writing a plugin. There are circumstances where if you're at some embedded thing, but you can't have a JVM in that circumstance.
Yeah.
So Roc says, let's focus the language on the specific domain that we're building for, or let's focus our applications on the specific domain. And so how this works is you build a platform in a language that supports the C ABI, and that platform knows everything about that specific domain. So this platform knows everything about building web servers, or this platform knows everything about building CLIs, or this platform knows everything about building editor integrations in this one specific editor. So that platform, the popular choices are Rust and Zig, but people also like writing them in Go. You can write them in many languages.
Yeah.
And that platform deals with those domain-specific details. It provides the concurrency model, if there is one. It provides all of the I/O operations, the effects that are relevant in that context.
So would I, hypothetically, I'm not sure if I've got time for this, but hypothetically, I write a web server in Roc and I expect to get that platform for free, but then I might go away and say, I would like a platform that lets me write Vim plugins. And it doesn't have any web primitives available at all, but it has editor primitives available.
Right, yeah.
If I did that, what would I actually do? Would I go and write some Rust code that integrates with Vim, or...?
Well, I am not well enough versed in what writing plugins in Vim is like. I think in Vim itself, it's like Vim script.
Yeah,
so
that's probably not great idea. But
what I imagine you would do is you would write sort of a shell, not a shell in the terminal sense,
a thin wrapper.
Yeah, in Vim script or whatever. And then that Vim script would take in the input from the editor that your plugin cares about, and then it would call the Roc code and do the conversions of the data types into the Roc data types and all that. So then that would be the platform. And then you import that platform in your Roc code, and now you have all of these Vim primitives that you can use to build your Vim application. And then that is how it gets embedded. Does that make sense?
Yeah. And as a user, I'm just writing normal Roc code that just happens to have a different set of APIs. Again, playing devil's advocate, why is that better than just having a Java, like Java has web libraries, but I don't use them?
Right.
Why have like a constraint?
That is an excellent question. Because you're right. Why does it matter? And that's not really that's not really the main point. The main point is that you get to have a context for writing your application that's very tailored to that domain. And I'm so glad you asked this, because I wanted to bring up Elm, because I know you like Elm.
I like Elm.
And Elm is it's magical. It's amazing. It's such a joy to use. And part of the reason that it's such a joy is that it's laser focused on building single page apps in the browser.
Yes.
And because of that, the language can include all of the things you need for building single page apps. It doesn't have a main function even. It has the Elm architecture functions that you use for this sort of event driven process for building the single page apps. And it means that you can get a beginner in Elm app, and it can be a really gentle introduction to functional programming, because there are just these three functions: init, update, view. I haven't written Elm in a while, but whatever. And
I think those are the three.
Yeah. And you sort of fill out those functions, and the language does everything else for you. That's amazing, but it's limited to primarily writing in the browser. So part of the inspiration for platforms is, what if we could have that sort of experience in every domain? So when you write a web server in Roc, you don't have a main function where you then call webserver.start or webserver.listen or whatever. You have a function called respond. And that function has a HTTP request as its first argument. So that's your entry point to the program. You can tailor your application to the specific domain you're working in.
It seems to me that architecture is going to be great for people that are getting started. It's going to have that great initial experience. My instinct would say eventually it's going to grow to the point where either you need a way to say, well, this application is mostly just a web server, but it also does some other stuff. How do we compose different platforms together? Or you're going to have people who are really good at building the platform underneath the language, such that building a custom platform becomes the norm.
Right. I think in larger companies, it'll certainly become standard. My prediction is that it will become standard for them to have their own platforms that they operate that can be tailored to their specific needs. But I also think there's a good chance that most applications will be quite content being one thing. So I'm curious, you say you have a web server and it's mostly a web server and it's a little bit something else. What could that something else might be? Like, what do you have in mind?
I can pick a very simple example, which is you might want a platform that's a web server plus Postgres, and someone else wants a platform that's just a web server plus Mongo, right? And you don't want like a Hibernate style API abstracting away, because those are actually two quite different databases.
Right. That's a great point. So, and I'm glad you bring that up because I can answer that quite well. So the approach there is that you would instead implement a client for Postgres in pure Roc code. And then your platform will supply TCP or whatever other primitives that client needs to interact with Postgres. But that client library can just be a pure Roc library. It can be shared across any platform.
Okay.
And the platform only has to provide that little primitive of TCP or whatever you're going to be using for your database. So there already is a Postgres client implemented in that manner, and it can be shared agnostically across platforms. So it's unlikely that you would want to build, you certainly could build a platform that had baked-in support for Postgres. One of the web server platforms has baked-in support for SQLite, but you don't need to do that. You could choose to implement your Postgres client as a platform agnostic library.
Okay, yeah, I can see it. That makes sense. But it also makes me wonder, am I then this relates to the composition thing. Am I then going to say, you know what, we are a reasonably large corporation. We just use web servers with Postgres. I don't want arbitrary network access. I want to build a platform that looks like how it would have looked if the Postgres client was just part of the platform. Is there going to be an easy way to say, to treat Roc platforms like a menu, where you choose the things that go together?
No. That's my understanding as of right now. Now, something could change perhaps, but there are a lot of issues that would come in with that because your platform's written in a particular language, and that language, that could be any language. So you'd have to do a lot more to make those sort of interoperable. You already can do some of that in that you could have a Rust platform that then use some shared Rust crates, for example, used by other platforms, or maybe that Rust platform calls some other language. So you can do things like that, but that's not a polished, planned experience at this point.
I wonder if it'll grow into one, because I totally agree with you that one of the joys of Elm is that it was totally focused on the function. I can see that spreading into other domains, but then I can see the management of those domains becoming a whole class of problems in itself.
I think this is WebAssembly has some similar stuff with sandboxing and things like that, but this is kind of a new direction, I think, at least. I could be wrong, so I'm sure someone in the comments will tell me about how this was done in the 60s.
Yeah, we used to have a COBOL platform that did this back in 63.
But I don't think we really know how it's going to play out. And so we'll just have to see what happens.
Okay, on that speculative note, I'm going to ask you one more speculative question, see if I can get a completely candid answer from you. So Roc has recently announced that it's rewriting the compiler from Rust into Zig.
Right.
What do you think of that?
I think it's an excellent decision.
Okay.
And
why?
I earlier in this conversation, I said I think it's a bad idea to completely rewrite large code bases. So I know, I'm aware of that. But Richard Feldman, the creator of Roc, he wrote up a memo, like a little internal memo, just shared in the Roc Zulip channel, which is public, but about the reasons for why the compiler was going to be rewritten in Zig, and he just wrote it up quickly, and then someone found it and shared it on Hacker News, and it was number 3 on Hacker News for 24 hours or something like that. So people were very intrigued. But over the last 9 months or so, a ton of changes have come to the language that are extremely exciting, and I believe will greatly increase the likelihood of the language succeeding because they maintain all of these wonderful functional guarantees we want while making the language much friendlier and easier to use. Those changes changed a lot of core assumptions about the language, such that the existing compiler is going to have to be most of it was going to have to be rewritten anyway to support those new features.
One of those is you're changing syntax, right? You're putting braces in.
Right. Yes, that's part of it. But a lot of other parts of the internals will need to change. Major features being ripped out, major new features being added in. So the thought was, well, it would be nicer to have a compiler written in Zig. That's the preference of the team, rather than Rust. And so if we're already going to have to rewrite everything, we might as well, this is the best time ever to switch to Zig. So now you say, okay, why would it be nicer to have a compiler rewritten in Zig? One of the biggest reasons is compilation speed. Rust has slow compilation speeds, especially when you get into a large project. No, they're not slow if it's a small project, but if it's a big project, it slows down a lot. And that really makes developing a code base difficult. So I'm not a core contributor by any means, but I've made contributions to both the old and new compiler. And in the old Rust compiler, I would make a change, write a test, hit Rust test, and I'd sit there for 6 minutes or something.
Really, that
just waiting for everything to build. And I'm sure there are things I could have done to make things better, but this was a constant pain that the developer experience was was really rough because of the compile times. Zig is extremely focused on fast compile times. They're doing a ton of work on that. And so it's so much more joyful to use. Like it was announced that it was decided that it was going to be rewritten in Zig, and that immediately made me feel more excited about contributing to the compiler in the future, because I knew that I could get faster feedback when I was changing it. Because this is something I'm doing in my fun, not paid developer time.
Yeah.
I don't want to spend all my time sitting around waiting for the compiler in that circumstance. Then the compiler is very focused on performance, and Zig is a nicer fit for the philosophy used to achieve that performance. So one big piece, okay, so part of this is that the compiler does some, so Rust tries to avoid you doing memory unsafe things altogether, but inevitably there are some circumstances where you need to use an unsafe block, so I can do this unsafe thing because whatever reason, that's just what I have to do.
Okay.
Then once you do that, now you're in no man's land and you have very little support, and that experience is now worse than it would be if you're using a language that expects you to do unsafe things more consistently and tries to support you in that paradigm. It turns out that there is a fair amount of this unsafe sort of code in the Roc compiler. So much so that this is part of the reason I believe why the standard library was rewritten in Zig in the original compiler. So the original compiler was Rust on Zig, because Zig was so much better of a fit for writing this kind of code being used there.
Yeah.
So then rewriting the whole compiler in Zig, that philosophy can be used everywhere. And then also, the structure of arrays optimization is used a lot, and Zig has much nicer support for that than Rust. Again, this is my understanding.
Okay.
And there are some other reasons I'm forgetting, but those are some of the main ones.
Okay. In that case, I'm going to ask you a final question, because I'm working on a project completely unrelated to this, but it's in Rust. And I was tempted to use Zig. I'm very drawn towards Zig. These are my scars from the past, but I am probably more worried about memory management than compile times per se.
Mm-hmm.
I hope I never have to deal with a seg fault again in my life. Does that side of Zig worry you? Is it proving a problem for the rewrite? Am I being too cautious about it?
It doesn't seem that worrying to me. And this brings up another point about Zig, which is that in the context of a compiler, you're taking in code, you're spitting out an executable. You don't really need to be freeing a lot of memory as you're going. Rust naturally wants you to allocate lots of little objects that are then freed as they go out of scope automatically. That's not necessarily a good fit for a compiler where you're going to take in code and spit out an executable. You could certainly do all the deallocations there, but Zig is much more aligned with the idea of, here's a big chunk of memory, I'm going to put a bunch of objects in it and then throw it away at the end.
Yeah, okay, that's a very good fit for compilers.
Right. So that works nicely with the compiler. And then also, because the intent is that it's going to be an executable that's invoked quickly and then is done, it's the importance of memory safety is less, I would say.
Yeah. For a one-shot program like that, the best memory strategy is just allocate and don't ever release it until you're done.
Right.
Yeah, okay. So, final question then. What does your future hold, like, computing-wise? Do you think... What's the most exciting software reliability technique that you want to look at next? That's very nebulous, but I'm going to ask.
Well, I'm going to shift gears back to another one, loop back to earlier in the conversation, the one that I haven't talked about yet, which is back to invariants. So the idea is we have properties about our system. I want us to think about these properties. We should start by enforcing these properties using the type system where we can. Mm-hmm. Once that runs out of gas, start using runtime assertions. Once runtime assertions run out of gas, start running queries against your data and checking if your data makes sense. And this is something we just started using at work last week before the conference, and it's already found multiple bugs.
What form does that take?
Right. So
Are you like running invariant queries over your log files, or are we talking about like we should have a schema on our database or something?
So our particular implementation, and this could very well change, is we have a read replica. I created a directory in the root of the project called data invariants, broken out by team. In each team directory, you put SQL files. Those SQL files must all return a count. And every night we'll run those queries, each of those against the read replica. And if any of them return a result other than 0, then we'll send a Slack message telling you this invariant was broken. We expected this to return 0 rows, but it returned 74 rows. That's the implementation we have now.
Right, yeah.
We could very well change that. We have a small enough amount of data, or there are many queries we can run that are fine to run against a transactional database, MySQL in this case. If that became a problem, we could change the architecture and start running these against BigQuery or something like that. But this was a very quick, easy way to implement it, to test it out.
This is a way to do like the kind of checks that a database schema generally can't look at values, just types.
Well, so you should absolutely use database constraints. I love database constraints. They're amazing. I think lots of people like database constraints because they give you a lot of peace of mind.
They do.
And database constraints are runtime assertions in your database.
Yeah.
If you do something wrong, it blows up and it's loud. So that's it. We're sort of just doing database constraints in your code with runtime assertions. But again, yeah, there are properties that you can't enforce with those constraints, because even if you were to check constraint, usually those can only apply to like the current row or table, and you can't check properties that apply to many tables in your system.
Yeah.
So one example, we make an employer benefit. Once an employer, if an employer has terminated their contract with us, then we don't want any of their employees to still have access to the product because they're the one providing the product, they're sponsoring it.
That makes sense.
That's very reasonable. But so you could express an invariant, every employer that's, for every employee, if their employer is terminated, they must be inactive. It seems like a very reasonable thing to say.
Yeah.
But it's a hard thing to enforce if you're just at runtime, because
hard to impossible to do at the schema level.
Right. Well, you certainly can't do that at the schema level with a normal database constraint. You could write a runtime assertion where, say, when some request is processed, you run this query or load all of the employees or something like that. But that's obviously horrible because you can't afford to be doing that. And then in this particular case, when we terminate an employer, there's actually a window. The process of updating all of the employees is asynchronous. So there's actually a window where there could be employees that are still listed as active, even though the employer is terminated. And so how are you supposed to accommodate for that also? But we can encode all of this in a query. So the query says, for all of the terminated employers within some grace period to account for the asynchronous aspect, make sure that all of those employees are also inactive. And the feature I mentioned at the beginning of my talk that I was working on, that was a challenge that I was distracted by these unnecessary pain points of the tools. Well, as part of that feature, there was one particular subgroup of employers that needed some special treatment. So I wrote a job to backfill some data they needed for them. And in doing that, I forgot to call a function that I needed to call on each of those employers. And it was completely not noticeable at all. You would have had no idea because everything still looked as though it was working. The data all seemed fine. And then I implemented these checks and I found, one of those checks failed. And it said, I forgot to call that function on those employers. I need to go back and fix that. And this is the sort of thing that it could have literally gone years without ever being noticed because it's one little corner of the data set. You have so much data. How are you to know if one little corner of it is wrong? But now I have feedback and confidence. And if anything slips through the crack anywhere, well, that can still be caught by this check over the data because it checks the data at rest. It doesn't matter if that data is currently being processed to have an assertion go through it. It'll keep checking it consistently.
Yeah. It's amazing how often it just comes back to, do you want feedback? Do you want it sooner?
Right.
That's the whole, maybe it's not the whole of software reliability, but it's certainly a pillar of it.
Right. And on the topic of feedback, with my pyramid here, Typesystem first, That's the best. Fastest feedback, no impact. Then runtime assertion, because you still get quite fast feedback. The bug's going to be caught quickly. You know immediately. Then at the bottom is these checks over the data itself.
Yeah.
I'm running that nightly, so it could be several hours before I notice the bug. So I'm getting less feedback, but now I have the most expressive power where I can express any sort of invariant that maybe I couldn't in either of the top two layers.
Yeah. I'm right at the bottom in the basement where nobody wants to go. The users just complaining.
Right.
Yeah.
And I encourage you, if you're listening and you have access at your company in some capacity, to start snooping around in your data and write these. Think about what properties must hold in your system, what the rules are, and start writing queries to check these properties. And I suspect that you may be surprised at how many of them fail in some edge cases. Now, it may not be the case that everything is completely broken, but it could be that 0.5% of your rows are wrong, and you have no way of noticing that because it's not clear that it's wrong when you look at your system normal.
Yeah. If you go looking for problems, you will almost certainly find them.
Right.
But it's probably better than the alternative.
Absolutely.
On that note, Isaac, we need to stop recording and go and look for some new problems.
I guess so.
Cheers.
Thanks for having me.
Pleasure. Thank you, Isaac. A lot of food for thought there, and I suspect some people are going to have their own 2 cents. So if you want to add your thoughts to the discussion, I invite you to head to the comment box. One topic I noticed, listening back over that we really didn't touch much at all, was testing. And I think that's a phenomenon of test-driven development. I think in a post-TDD world, we take testing as a given, and that can only be a good thing. But if you're hungry for some testing-specific discussion, have a look in the show notes for a link to the episode I did with Oscar Wickstrom, which was all about property-based testing. I still think property-based testing is the most interesting but underused technique in all of software testing. I like it so much, I've got a walkthrough video for it on YouTube. You will find both links for that in the show notes. While you're deciding where to click next, maybe one of those links or maybe somewhere else, please do start by clicking the like, rate, share buttons. It really does help. I await my judgment in the next life, in the great beyond, but in the here and now, the algorithm judges us all, and you can help it to look favorably upon me. We'll be back soon with an episode that takes Isaac's idea of querying a whole system and says, actually, how do you query a whole system? Sometimes that's much harder than it seems. I leave you pondering that thought. We'll be back soon with details, but until then, I've been your host, Chris Jenkins. This has been Developer Voices with Isaac Van Doren. Thanks for listening.